Honors Algebra 2, Chapter 14, Section 3. This will be day 1 of 2 days on this section on identities. There's a bunch of identities we'll use in trig, and we use them to simplify problems, to manipulate problems, to verify, and help us solve. So it's going to be used in various sections. But here are some of the ones we already talked about in our actual class. Reciprocal identities. We've done that. Cosecant theta is 1 over sine theta. Secant is 1 over cosine theta. And the cotangent is 1 over tangent theta. So you should feel pretty comfortable with these. The tangent cotangent identities, tangent of theta is equal to sine of theta over cosine theta. And then cotangent is just going to be reciprocal, cosine theta over sine theta. So these are all equivalencies we should realize. When we see a tangent, we should also think of sine over cosine, which we've already been doing in class. Pythagorean identities, and here's some new ones we needed to use. Sine squared theta plus cosine squared theta equals 1. And if you think about Pythagorean identity, where does this come from? Our cosine is really our x value. So if we deal with our cosine is like x, sine is like our y on the unit circle. So if we do cosine squared, sine squared, we get our hypotenuse squared, but again on the unit circle that's 1, so we get 1 squared. So hopefully you can see where sine squared plus cosine squared equals 1 comes from. But we also have some other ones here, that the 1 plus tangent squared equals. Now, this equals, if I think about tangent, tangent is sine over cosine. Now we're doing tangent squared, so this means sine squared over cosine squared. Because this has a denominator of cosine, it's going to equal the ratio that has a cosine squared on the denominator. That's 1 over cosine squared. So 1 over cosine squared is equivalent to secant squared. So that's how I memorize these, is that they have to have the same denominators when they're in the quotient form. So 1 plus cotangent squared is going to be cosecant squared theta. And those would be the Pythagorean identities. Cofunction identities. On the unit circle, if we look at 30 degrees here, the cosine of that, the x value, is root 3 over 2. That x value here is equal to the y value in the pi thirds, the 60-degree triangle. Those are the same. If you look at our angles, 30 and 60, those add up to be 90 or pi halves. And so this works with all of these angles. Whenever you have an angle and its coterminal angle, the measure of sine and cosine of those two are equivalent. So like sine of pi over 2 minus theta is going to equal cosine of theta. Cosine pi halves minus theta is going to equal sine of theta. And tangent pi halves minus theta is equal to cotangent theta. The negative angle identities, sine of negative theta is equal to negative sine theta. Cosine of negative theta is equal to cosine theta. And then tangent negative theta is equal to tangent theta. And that's where if you look at that negative angle, what's that equivalent to? Anything will have a negative value. It's because the sine and tangent here are both the y values of sine, and that affects the tangent as well. So we can use those to help us find some values. Sine of theta is 4 over 5, and we are between pi halves and pi, so it's the second quadrant, quadrant 2. Find the values of the other 5 trig functions. So I could just do like sine squared plus cosine squared equals theta equals 1. So I can plug in my sine squared, so I could do 4/5 the quantity squared plus cosine squared theta, I get 1. So 16/25. I can subtract it to both sides. So cosine squared theta is going to equal 9/25. I can square root both sides, so I find cosine of theta is equal to 3/5. And so I can use this ratio along with our sine to find our tangent. Our tangent value is just sine, which was 4/5, divided by cosine, which is the same as multiplying by reciprocal. And multiply those, you get 4/3. So I can just use my identities to evaluate that. I could also draw it. I could draw it because I'm not quite right yet in my values. Some of you are saying that, hey, those are wrong. But if I look at this, sine is the opposite over the hypotenuse. And then if I look at Pythagorean theorem, this is going to be 3. But we are in quadrant 2, so this is a negative 3 because we're going left, which makes this a negative 3, and then makes this a negative 3. I could have found that in the original problems by looking at the all students take calc and know that the only thing that's going to be positive here is our sine value. So all students take calc becomes even more important sometimes when we're using identities to make sure that you have the correct sign for the quadrant you're in. Simplifying expressions, tangent of pi over 2 minus theta is part of this, but it's multiplied by sine theta. What is tangent pi halves minus theta? That is equal to cotangent theta, still times sine theta. So when we are simplifying, we're trying to write this with the least amount of functions possible. So that helped out. We have less of a parenthesis quantity, but I can keep breaking this up. Cotangent is cosine theta over sine theta. I'm multiplying that by sine theta. So there, these sines reduce out, so I only get cosine theta. That would be the simplified form. This is equivalent to cosine of theta. Writing cosine theta is not enough. You have to show the work on what you're doing algebraically and using what identities to find that simplified form. Another one here, we have cosecant, cotangent, and plus 1 over sine. So I think 1 over sine is cosecant. So I might want to write that first. And I noticed that this also has a cosecant here. So now I have two terms that both have cosecant, so let's try factoring that out. We get cotangent squared theta plus 1. So this is a Pythagorean identity where that's cosecant. The cosecant theta times cosecant theta, which ends up being cosecant squared theta, would be the simplified answer. Simplifying the expressions. So here we have tangent of negative theta, which is the same as negative tangent of theta times cosine theta. Tangent is sine over cosine times the cosine. Cosines here will reduce, so I end up getting negative sine. Last problem here, we have sine, cosine, and cotangent. I need to figure out how to manipulate this, where I see cotangent can be changed using sine and cosine. So sine theta plus, there's nothing to factor out, so I know I couldn't factor, but cotangent I can write as sine theta, reverse. Cotangent is cosine theta over sine theta. So this is sine theta plus cosine squared theta over sine. So I want to add these, so let's multiply this first fraction by sine over sine. So you get sine squared theta over sine plus cosine squared theta over sine, which the numerator to add that is sine squared plus cosine squared, which is 1. It's 1 over sine, and 1 over sine is equal to cosecant theta. So that would be the simplified form. There's a lot to manipulate. It's a big puzzle, and simplifying is actually harder than verifying because you're not quite sure when to stop. Verifying kind of gives you the end result. We'll do that in the future here, but simplifying is you go through a lot of your algebraic concepts using your trig functions. So I'll call it good for the night, and we'll see you tomorrow.